Good morning, children. In the last lecture, we have seen problems based on speed and also on fraction. Today, I will be doing one more sum based on speed. The problem is written on the board here. A boat travels 16 km upstream and 24 km downstream in 6 hours. The same boat travels 36 km upstream and 48 km downstream in 13 hours. We have to find the speed of the boat in still water, and also we have to find the speed of the water current. So, this is very important from the examination point of view, very important sum which carries 4 marks. So, try to understand the problem. Here we have a boat which is travelling upstream and downstream. Now, first of all, you should know what you mean by upstream and downstream. Now, you know that water is flowing in a river. So, when water is flowing, the direction in which the water flows, that is said to be downstream. And if you are moving against the flow of water, that is said to be upstream. So, try to understand the difference between upstream and downstream. Upstream is the motion against the flow of water, and downstream means the motion along with the flow of water. Now, obviously, when I say that the boat is travelling downstream, means in that case you know that the speed of the boat is going to increase. The speed of the boat is one factor, speed of the water current is second factor. So, when they are moving in the same direction, they will get added. So, you have to remember here, when the boat is moving downstream, the speed of the boat and the speed of the water current will get added, means they will add, and that is why the speed of the boat will be more in case of downstream. On the other hand, when the boat is moving upstream, it is moving against the water current. So, definitely when you are moving in the direction opposite to the water current, your speed is going to decrease. So, in this case what is happening is, in case of boat moving upstream, the speed of the boat will be less. Speed of the boat, I said, which boat, which speed? The resultant speed, not the speed of the actual speed of the boat. Actual speed of the boat will remain same, but when you are moving upstream, the resultant speed, that is speed of the boat and speed of the water current, will get subtracted, and that is why the resultant speed of the boat will be less than the actual speed of the boat. I hope this is clear. So, remember one thing in short, when the boat is moving downstream, the speed will get added. You have to add the speed, both speed of the boat and speed of the water current. On the other hand, when you are moving against a water current, the speed, net speed will be difference in the speed of the boat and speed of the water current. Now, when we are going to see what will be the net speed of the boat when it is moving downstream. So, for that I will assume, suppose the speed of the boat in still water, speed of the boat in still water is say x kilometer per hour. Now, I use the word still water, means what? Where there is no water current, only speed of the boat. Consider only speed of the boat. So, let the speed of the boat in still water be x kilometer per hour. So, I will write that so, my first, how are we going to start? Let the speed of the boat in still water be x kilometer per hour. Do not forget this word, in still water. Then, if x is the speed of the boat in still water, then I have to assume the speed of the water current. So, let the speed of the water current be xy kilometer per hour. So, let the speed of the water current be y kilometer per hour. I hope this is very much clear to you, that speed of the boat in still water is x kilometer per hour and speed of the water current is y kilometer per hour. Now, you know the speed of the boat, you know the speed of the water current. Now, we are going to find out the speed of the boat downstream. As I told you, when the boat is moving downstream, the resultant or the net speed of the boat will be the summation of speed of the boat and speed of the water current. So, speed of the boat downstream will be equals to, I told you, sum means we have to add. So, speed of the boat is x and speed of the water is y. So, x plus y kilometer per hour. So, remember the net speed of the boat downstream will be x plus y kilometer per hour. Now, we are going to see what will be the net speed of the boat upstream. Now, in this case we have to be careful, because the net speed will be the difference of the two. Of the two means difference of the two speeds, that is speed of the boat and speed of the water current. Now, obviously you know that speed of the boat has to be greater than the speed speed of the water current. What I said? I said speed of the boat has to be greater than the speed of the water current. What will happen if the speed of the boat is not greater than the speed of the water current? That means, if the speed of the water current is more than that of the speed of the boat, then the boat will not go upstream, it will flow downstream only. Why? Speed of the boat is less and speed of the water current is more. So, obviously, the water current will take the boat along with its current. So, in this case, we have to be careful and say that the speed of the boat is greater than the speed of the water current. It is understood, obvious it is. So, here speed of the boat upstream will be equal to x minus y kilometer per hour. So, try to understand this. Speed of the boat upstream will be x minus y kilometer per hour. As the speed of the boat is bigger, so I will take x minus y. Do not write y minus x, because y minus x in this case it is means that the water current speed is more than that of the boat, and therefore, in that case you will not get this result saying that the boat is going upstream. So, in this case it has to be x minus y, provided your x is the speed of boat in still water. I hope this is clear to you why I took x minus y and not y minus x, because speed of the boat is greater than the speed of the water current. Once you get the speed of the boat upstream and downstream, now we know the distance covered upstream and distance covered downstream. Now, 16 kilometer upstream, it has covered distance of 16 kilometer upstream. Now, you know the distance covered upstream, you know the speed of the boat upstream. So, I can find the time taken to travel that 16 kilometer distance with the speed. So, how to find the time? We have seen in the last lecture that time is equals to distance upon speed. I write this here, time is equals to distance upon time. So, if you know this time is equals to distance upon time, if you know that this formula, time is equals to distance upon speed, then you can easily tell me what will be the time taken by the boat to travel 16 kilometer upstream with the speed x minus y. Correct? So, you know the distance. What is the distance upstream? 16 kilometer. What is the speed of the boat upstream? X minus y. So, time taken in that case will be, say I will write T1. So, T1 is equals to 16 upon x minus y. What is my time T1? My time T1 is the time taken by the boat to travel 16 kilometer upstream with the speed x minus y. See, the speed of the boat upstream is x minus y. Do not take x plus y. X plus y is the speed downstream. So, be careful here. Time taken to travel 16 kilometer upstream with the speed x minus y, because you know the speed upstream is x minus y. So, time T1 is equal to 16 upon x minus y hours. Time. So, unit is hours. Similarly, what is the time taken by the boat to travel 24 kilometer downstream? Now, how much distance is covered? 24 kilometers. So, that time I will take it as say T2. So, T2 is equals to, what is the for distance covered? 24 kilometer, 24 kilometer downstream. What is the speed of the boat downstream? X plus y. So, distance upon speed. So, 24 upon x plus y is the time taken by the boat to travel distance of 24 kilometer downstream, right. Now, you have calculated the time taken by the boat to travel upstream and downstream. So, you can find the total time. So, what is the total time taken by the boat to travel upstream and downstream? It will be addition of these two time. T1 is upstream, T2 is the time taken to travel downstream. So, total time will be T1 plus T2. So, you get here T1 plus T2, but what is the total time taken by the boat to travel upstream and downstream? It is given to me as 6 hours. The total time taken by the boat to travel upstream and downstream is given to me 6 hours. So, T1 plus T2 will be equals to 6. This is how I am going to get one equation now. Now, I will substitute the value of T1 and T2. What is my T1? 16 upon x minus y. What is my T2? 24 upon x plus y is equals to 6. See, I substitute the value of T1, 16 upon x minus y, plus T2 is 24 upon x plus y is equals to 6. Now, you got an equation here. Is this a linear equation? No. So, you have to reduce this equation to a linear equation. So, what I will be doing is, I will substitute. So, you know how to reduce a non-linear equation to a linear equation. So, last lecture I had explained to you, what you do is, you take the variables which is in the denominator. So, 1 upon x minus y as a. So, let 1 upon x minus y be a and 1 upon x plus y be b. As I told you in the last lecture, 16 upon x minus y. So, what I will get is, I will get 16, 1 upon x minus y is a, plus 24, 1 upon x plus y is b. This is equals to 6, and this is my equation number 1. 16a plus 24b is equal to 6 is a linear equation. From where? From this non-linear equation I reduce to linear equation. So, this is my equation number 1. So, this is how I get equation number 1 from the first statement, or you can say by the condition 1 which is given in the problem, that is up till here. Now, to get the second equation, read the second sentence. The same boat travels 36 kilometer upstream and 48 kilometer downstream in 13 hours. So, now you know how to form the equation, because already you know how to get this. So, you know that 36 kilometer upstream. So, if you know the distance traveled 36 kilometer upstream, how much time it will take? Distance upon speed. What is the distance? 36 kilometer. What is the speed of the boat upstream? X minus y. So, time will be 36 upon x minus y. I will write that. So, by second condition, 36 kilometer it has traveled. So, 36 kilometer means 36 is the distance. Speed of the boat upstream is x minus y. Now, this is upstream. Now, downstream it has covered 48 kilometers. So, you know the distance traveled downstream, which is 48 kilometer. You also know the speed downstream, which is x plus y. So, time taken will be 48 upon x plus y. So, this is the time taken to travel upstream. This is the time taken to travel downstream. Total time is given to me. So, total time means addition of these two, and that is equals to given to me 8 hours. So, time is given to me 13 hours. It is given 13 hours. Is this clear? I will repeat again. By the second condition, time taken to travel upstream is 36 upon x minus y. Time taken to travel downstream is 48 upon x plus y. Total time given to me is 13 hours. All that is given in the problem. Read it carefully. Everything is given. Now, again, your 1 upon x minus y is a, 1 upon x plus y is b. So, here you will get 36. 1 upon x minus y means a, 48. 1 upon x plus y means b, which is equals to 13, and this is my equation number 2. So, this is how I get equation number 1 and 2. This is very important. If you make any small mistake, your full problem will go wrong. So, this is how you get the equation. Now, once you get these two equations, now it is up to you how to solve this, by Cramer's rule or by elimination method, right. So, we will solve it by here elimination method. 24b is here, 48b is here, plus 48b plus 24b. So, what I will do is, if I multiply equation 1 by 2, I get here 32a plus 48b is equals to 12. Okay. So, I will write this equation multiplying (32a) plus 48b is equals to 12. This is my equation number 3. Now, try to understand. Now, all of you know why I did this, why I multiplied equation 1 by 2, so that I will get here 48b, and if I get here 48b, I can just subtract equation 2 and 3. So, this 48b gets cancelled. That is why I multiplied equation 1 by 2. Is this clear? Now, you got equation number 2, you got equation number 3, 48b. So, subtracting equation 2 and 3. We get, what we get? See now, 36a plus 48b is equals to 13. 32a plus 48b is equals to 12. I am telling you again and again, when you are subtracting, the sign changes. So, 36a minus 32a gives me 4a. 13 minus 12 gives me 1. So, I get a is equals to 1 by 4. I get a is equals to 1 by 4. Now, once you get the value of a, you have to find the value of b. So, I will substitute the value of a in one of the equation. So, I will substitute in equation number 1. Substitute a is equals to 1 by 4 in equation number 1. What is my 1? 16a plus 24b is equals to 6. So, 16a, what is my a? 1 by 4 plus 24b is equals to 6. 4 ones are 4 fours are. So, 4 plus 24b is equal to 6. So, 24b is equal to 6 minus 4. So, 24b is equals to 2. So, b is equals to 2 upon 24. So, b is equals to 1 upon 12. So, I got a is equals to 1 upon 4 and b is equals to 1 upon 12, right. This is not the end of the problem. Resubstitute for a and b. What is my a? My a is 1 upon x minus y and my b is 1 upon x plus y. I repeat, resubstitute for a and b, you get this equation. Now, again this is in the denominator. So, taking reciprocal on both the sides, for both the equation you get x minus y is equals to 4 and x plus y is equals to 12. You get again two linear equations. Call this as equation number 4 and this as 5. Solving this 4 and 5, you get your values of x and y. So, adding equation 4 and 5, x minus y is equals to 4, x plus y is equals to 12. So, adding you get 2x is equals to 16. Therefore, x is equals to 8. So, I got my answer x equals to 8. Substitute x equals to 8 in equation number 4, I will put in 5, in equation number 5, that is x plus y is equals to 12. Equation number 5 is x plus y is equal to 12. Put the value of x 8. So, 8 plus y is equals to 12. So, y is equals to 4. So, finally, I got the value of x equals to 8 and y is equals to 4. So, I told you this is not the sum where you write the solution set. Here these are word problems, you have to write the answer in words. So, answer finally should be written. Therefore, speed of the boat in still water is 8 kilometers per hour and speed of the water current is 4 kilometers per hour. This completes your sum, which carries 4 marks, right. I hope you understood this. This sum is very important from the examination point of view, from the board examination point of view, and therefore, practice this, read it, practice it, and again redo it so that you will understand. I will stop here by saying that we have finished the first chapter, that is linear equation in 2 variables. In the next lecture, I will be starting with the quadratic equations. Thank you very much.